right, welcome to the Unit 2 end of unit assessment review. I'm going to do a couple problems and then I'll stop the video and I'll make another video every couple problems. So we're going to start this off with question number 1. And this is part of the section where you could use a 4-function calculator or you could use a scientific calculator, but not a graphing calculator. There will be a Desmos section, and I will make a video for the Desmos section as well. Okay, so the first question says, select all true statements about P of X. So before we start looking at our options, I think it's important to understand this polynomial and what it tells us. So the first thing that I want you to recognize about this is that it is a degree of 3. And that's because the largest exponent is a 3. And what we need to know about that is that it is an odd degree. The next thing that we want to notice here is that the leading coefficient is negative. And if you look at the number that's attached to x cubed, you see it's a negative 3. So the reason this is important to know is because when you know the degree and the leading coefficient, you can understand what direction the arrows are facing. So we know that an odd function has opposite arrows, and we know that the negative sign will make the left arrow up. So one thing I want to do right now is just remake this box for all of you. And this is a box that you should be able to make come the test. So the first thing that we look at is even and odd, and then we look at positive and negative. So just to make this chart for you, we would just change my pen. So if we saw that it was even degree and positive leading coefficient, we would see the arrows go up, up. And when it's even and negative, the arrows pattern is going to be down and down. So the odd ones are going to be opposite directions. And whenever something has a positive leading coefficient and it's odd, the arrow pattern is going to start with down, up. And if the leading coefficient is negative, it's going to start with up and down. So what you should notice right now is that this version, this odd and negative, is right here. So what we're going to have to do in the multiple choice options, so we're going to look and see which set of notation tells us up and then down. So I'm going to start looking at all my multiple choice options, and the first one shows us that the x approaches negative infinity, and the function would also approach negative infinity. So that means the left arrow is going down, and as x goes to the right, the function is also going down. So that means that this first option is the down-down pattern, and that is not what we know this to be. We know right here that the up-down is going to be the one we're looking for. So right away, I'm going to eliminate that option for myself because I know that that's not the right one. Okay, the next one we see as x goes to the left, the function arrow goes up. And as x goes to the right, the function arrow goes up. So this one was our even and positive pattern, and that's not what we're looking for. So that is not our response either. This one is saying as x goes to the left, the function goes down. So that would be the first arrow down. And as the function goes to the right, the function goes up. So this would have been our odd and positive pattern, not the one we're looking for. So we're really hoping that this next one is ours. And if you see this one, it says x approaches the left, the function arrow goes up. And as x approaches the right, the function arrow goes down. So this is our correct choice for the end behavior. We mark that as correct. And then we're going to analyze these last options. So let's remember that P of x had a leading term of negative 3x squared. And also, an important thing to notice is that there was no number at the end of this. So technically the constant is 0. So we know that this function was negative 3x squared. Then we had some more terms. I'm sorry, 3x cubed. Not going to restart the video, sorry. But notice right here that there's technically like nothing there, so the constant is 0. So we want to note here that the constant of the function is 0. So these last options can be decided on by analyzing the fact that this is a third degree, it is odd, and then we know the constant is 0, so we know it's not positive and we know it's not negative. Neither of those choices at the bottom, that's not an answer and that's not an answer, that's not an answer as well. So your two correct responses here are that the degree of the function was odd and that the end behavior was up then down. So that's question 1, and I would definitely expect you to see something like that on your assessment coming up soon. So the next problem, number 2 and number 3. So number 2 and number 3 are definitely challenge problems, and I would say that you would only need to expect one of these challenge problems, and it will probably only be worth 2 or 3 points. So we're looking for you to demonstrate a lot of understanding here in number 2, and I want to start you off by creating our reverse distribution box. Okay, in other words, the reverse box method. So anytime you see one of these problems and you are dealing with a cubic function, you want to make sure that you made 4 sections or 4 columns, and then you're going to make 3 rows. So what we notice here is that this is telling us that x minus 4 is a factor of the polynomial. So if it's a factor, that means I can divide out that factor. And so I'm going to put the x minus 4 over in the left part of the box. And then I'm going to show this p of x polynomial is going to be in our box. And we know that the first term is an x cubed, and that's the only term that's going to come from an x times an x squared. And then the only other part that we can fill in is the constant. We can put negative 24 down here. Okay, so it's our job to make sure that we fill this red space right here with the new polynomial. Okay, now we don't know exactly what the coefficients are. We know this one is negative k and we know this one's negative k. But what we should do to solve this problem is we need to begin the division process, and we're going to fill in as many boxes as we can before we try and figure out what the value of k is. Sorry, sip of coffee. So when we look at this, we're going to start by going down this box, and we need to imagine x times something gave us x cubed, and the correct term we're looking for there is x squared. So if we know x squared, we can fill this box in now, because x squared times negative 4 is negative 4x squared. So we know that whatever is in this box right here, right, that's a quadratic term, that is going to add up with this quadratic term, and it is going to make negative kx squared. So we don't quite know what that number is yet, so now we're going to start at the negative 24 and try to work our way backwards. So when I look over at negative 24, I'm picturing negative 24 is coming from negative 4 times something. And if we have a negative 4 and this stayed negative, that means that this is a positive 6. Because 6 times negative 4 is going to be negative 24. So from here, we actually don't have many more boxes to fill. We can fill the box underneath the plus 6, because plus 6 times x is going to give us plus 6x. So this is where we have to get a little creative, and this is where we are going to extend our knowledge. And we know that this is going to be something bx. Now, I'm using b because in standard form of a quadratic function, we let the variable of the linear term be b. So I like to fill in this part as plus bx squared. And we also know that negative 4 times bx is negative 4bx. So now we're going to use our highlighter to show that this box plus this box must equal this box right here. So how I'm going to write that out is I'm going to use bx, oops, sorry, that's an exponential, whoopsies. Bx squared minus 4bx squared. Oh, I apologize. I need to get okay. Two highlighted boxes. Bx squared minus 4x squared, and we know that has to equal negative kx squared. So from there, we have one equation that creates the x squared. I'm going to take the other, and we know that negative 4bx plus 6x must be equal to negative kx. So I'm going to set that equation up as 6x minus 4bx equals negative kx. So this is a lot of math to get to that missing number, but now we can actually get rid of all the x squareds and all the x's because those are consistent in each problem. And what that does is it creates b minus 4 equals negative k. And if I know that b minus 4 equals negative k, I can compare that with 6 minus 4b equals negative k. And so I want to make sure that you see I'm taking the 6 minus 4b equals negative k. And I'm also taking b minus 4 equals negative k. And so what's special about this is that if I know negative k and negative k are equal to these two things, I can set b minus 4 equal to 6 minus 4b. And from there, we can combine our like terms. I'll add 4b to both sides. And I will add 4 to both sides. And we get 5b equals 10. And b equals 2. So that's a lot of math. That is something that we will need to practice. And we can practice it with the second problem of the type with number 3. So let's try that one now. So we're going to run this from the top now, okay? So we are going to make our box. We're going to divide out the known factor. So the known factor has been given to us as x minus 2. So x minus 2 goes in this box. I can start building the polynomial. I know x cubed goes here. I also know that plus 16 is going to go here. And from there, I need to start building anything I know about this division of the polynomial. I'm going to reference back to this box, and you know that the boxes that were highlighted, here, 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 and here, those are going to be empty. We won't know those for a little while, so we're going to say this yellow box, this yellow box are going to be equal to this part right here. And we also know that this box and this box are going to equal out our linear negative kx. So now we can start filling in what we know about this. We know that x would need to multiply by x squared to turn into x cubed. We also now can do x squared times negative 2. We know negative 2x squared. And We also can figure out this box because -2 times -8 would make positive 16. And if we go backwards, we can say -8 times the x is -8x. So we filled in everything we can fill in without using an extra variable. And now I'm going to go in and write a bx. We don't quite know what that number is going to be, but we can multiply it and we get bx times x to get bx squared. And -2 times bx is -2bx. So we can start filling in everything now. So I can write these yellow boxes as -2x squared plus bx squared. And that needs to equal -kx squared. And now I'm going to write the turquoise boxes. I'm going to say -2bx minus 8x equals -kx. So now let's get rid of all these x squareds and all these x's to try and make our equation simpler. So I'm going to write down -2 plus b equals -k. And the next equation is going to be -2b minus 8 equals -k. And so with these two equations, we know that the top equation is equal to -k and the bottom equation is equal to -k. So we're going to say -2b minus 8 equals -2 plus b. Notice that I took the top equation and wrote it here, and I wrote the bottom equation and I wrote it there. So let's start solving for b. We're going to add the two b's over, and we're going to add the 2 over. So I get -6 equals 3b. Divide both sides by 3, and b equals -2. And there you have number 1, number 2, and number 3. I'm going to check the time. All right, let's begin another page. So that was numbers 1, 2, and 3. I definitely think 2 and 3 are challenging problems, and I think that you should only expect one of them, and it's only going to be worth 2 to 3 points. So it is a part of the quiz, but it's not I don't think it's the focus point of the quiz. Okay. So let's talk about number 4 and number 5. This is when we need to basically factor the polynomial. So when you read this phrase, write the equation as a product of linear factors. Okay, that means that they want us to write g of x as some set of parentheses times another set of parentheses times another set of parentheses. And in this problem, I know that this is a cubic function. So a cubic means a degree of 3, and that means we're going to have 3 factors. So we already know one of these factors. They've told us that 2x plus 1 is one of them. So if I use 2x plus 1 as one of the factors, I can start breaking this down by making a division box. So we make our division box. We're going to make 4 columns. And then we're going to make 3 rows. And I'm going to put the 2x plus 1 in the box. And then I'm going to start putting the polynomial g of x into our division box. So that would have to be 2x cubed. This is going to have to be plus 5. And now we can start figuring out where everything needs to go. So I know this would have to be an x squared because x squared times 2x gives us 2x cubed. And then I can start filling in other parts of this. So x squared times 1 is going to be plus 1x squared. And now I start looking up at the top here. And I want to compare 1x squared plus something is going to give me 13x squared. So 13x squared would be 1x squared plus something. And if we do 1 away from 13, we can figure out that that should be a 12x squared. But to make 12x squared happen, they multiplied 2x times something. So for us to figure that part out, we know that 2 times 6 would be 12, and x times x would be x squared. So essentially, what we just learned is that g of x can be written as a product of two factors to start. And it means that I am almost at my final answer for the red polynomial. So we're trying to figure out that last part of the constant, and we can do that by working backwards, just like we found x squared. So I can say that 6x times 1 would be plus 6x. And I can also tell you that this box, 6x, plus this box, has to be equal to 16x. So if I go over there and I say 6x plus something must be 16x, we can easily fill that in. 6 plus 10 is going to be our 16. So that means that last box has to be filled with a 10x. And when I start thinking about how to fill that box in, I have two approaches. We can do 1 times something is 5, in which case I know it's plus 5. Or I could check that 2x times 5 is plus 10x, which it is. So what this tells me is that my final piece of my answer is a plus 5. And now we need to start thinking, how do I break down x squared plus 6x plus 5? Well, I need to think of two things that are going to multiply to 5, but they add to 6. So what we want to be thinking there is that 1 times 5 equals 6, and 1 plus 5, sorry, thinking too fast. 1 times 5 is 5, and 1 plus 5 is 6. So that tells us that we have x plus 1 and x plus 5, and that means that we can fill in our last bit. And now we have fulfilled the problem because they asked for a product of linear factors, and that's exactly what we did above. So the final answer would be g of x equals 2x plus 1 times x plus 1 times x plus 5. All right, so the next problem is going to be very similar, but we are going to have a little bit more of a struggle factoring that because we're not going to have a positive 1 as our coefficient. I believe this next one's going to have a coefficient of 3. So let's try number 5. So number 5 is the same process. We are going to set up a division box. And we are told that we have a known factor of x minus 5. So how we did this before, we're going to take the x minus 5, put it in the side box. And I also am told that 6x cubed is the leading term. And the constant is a negative 20. So from there I can start filling in my work. I know that x times 6x must be 6x cubed. And wait a minute, I didn't write a squared in yet. There we go. Now x squared, 6x squared times x is going to be 6x squared. I can now fill in another box. I can say 6x squared times negative 5 is negative 30x squared. And I can also start to pay attention to this negative 19x squared, because somehow we need negative 19x squared to pair up negative 30x squared with something else that gets us to negative 19. So one strategy you could use here is you could just add 30x squared to both sides. And then we get 11x squared. So we know that this must be an 11x squared. And we can start to make sure that that does equal out to negative 19. And negative 30 plus 11 does equal negative 19, so we're good there. And we need to make this a plus 11x. So plus 11x, we know, would multiply down here to be minus 55x. And so negative 55x must add to something to give us negative 51x. So the difference between negative 55 and negative 51 is 4x squared. So I'm going to add that part in, plus 4x squared. Oh, just 4x, sorry. No square right there. That's because this was an x, this is an x, and this is an x. So from here, we need to build in that last piece of the function, and we can get that from x times a plus 4 would give us 4x. So from here, we can start rewriting this polynomial. We know that g of x is going to be equal to computer's freezing. There we go. We know x minus 5, and we also know 6x squared plus 11x plus 4. So the last step of this process is to figure out the factored form of 6x squared plus 11x plus 4. So that's going to be a plus 4. This has to be a 6x squared. And when I start thinking of 6x squared, I start thinking of 2x and 3x. Now we could try 1x and 6x, but after many attempts and many tries, 2x and 3x are going to be what we're looking for. So right now, we want to try and figure out a way to make a positive 4. So you could try 2 and 2, but this ends up being a plus 1 and a plus 4. It means 2x times 4 is 8x, 3x times 1 is plus 3x, and this 8x and 3x does make 11x. So sometimes you guys are going to have to do a little trial and error to get there, but what we just learned is that 3x plus 4, 2x plus 1, and our x minus 5 is the factored form of g of x. Our final answer would be 3x plus 4 times 2x plus 1 times x minus 5 is our factored form, or we can call it a product of linear factors. Okay, so I'm going to cut the video off at the first 5 problems, and then we'll see how long it took, but I'm going to go around and pause the video and start making another one.